Welcome to the SaturdayMP show, episode number 38, being recorded mostly live, March 25th, 2024. This is a show about shipping secure, high-quality software faster. And today we're going to do that by, well, if you watched the last video, I was doing this picoCTF capture the flag events, and I got really stuck on this Stonks problem. And so today we're going to answer my own question on how to solve it. At least I hope I can, because I've done some research and I've solved a similar problem in the actual picoCTF 2024 competition, not in the gym, that had the same type of vulnerability. So that's what we're going to do today. We're going to answer my own question about the solving stonks. And maybe if we do that real fast, maybe we'll try and solve another one. Or maybe this will just be a short video. It's, as I said before, March is a busy month for me. So so I'm your host, Chris, and if you have any questions you'd like me to answer in a future video about shipping secure software faster, like how do I get software out the door, what's the best way to design this, how do I refactor this, you could send an email to ask@SaturdayMP.com, or just leave some comments below in the YouTube if you're watching this on YouTube, and I'll do my best to look at them and answer them in a future video. Yeah, so all right, I guess the other quick thing is if you have, if you like these videos, if you like what I'm doing, if you think they're useful and you think others would benefit from them, click the like and subscribe button, because that's the way other people find these videos. Is the more popular they are, obviously, the more people can find them. So if you find them useful and you want others to find them, share them, like, subscribe, all the things. If you don't find them useful, I guess go watch something. Go watch something else. I don't know why you're still watching this. It's kind of weird. And if you have any constructive feedback, like nice constructive feedback, don't make me cry or anything, feel free to also email me that or throw it in the comments below. Just don't be mean. Like I've said before, there's enough mean people on the internet. You don't need to add to that population. There needs to be more nice people. All right, let's jump right into this. I think the last video, I had no idea how to solve this problem. I think I was going this stonks. So for those that missed it, you could go watch this other video. This is a picoCTF practice problem, and it is set up to be, where's my view? There we are. So they give you basically the file here. This let's move this down a little bit more. It's basically a little C application called Stonks, which is for trading stocks. I've just been saying stonks so much. And it's got a little. Maybe I'll run it here in a minute, but it's got this. Where's the intro? So it basically starts by initializing a portfolio. So the actual stocks you buy doesn't really matter, as you'll find out. It's just gives you a random amount of money. It's basically just randomly generating some data. Prompts you, would you like to buy some stocks or view your portfolio? The view your portfolio, if you just click that, there's actually nothing in it the first time anytime you run it. So it'll return this, you don't have any stocks. But the real meat and potatoes is if you would like to buy some stocks. In that case, it'll take you, hopefully I'm not scrolling too fast, it will take you to this buy stocks method. And in here is this API buffer. So I think this is supposed to represent like somebody's incompleted program. So they have like a to-do here, forgot how to read the token for a file. But this is what we really want. We want to be able to read this API value. So it opens from a file, and that's fine. That's all great. And then this here just randomly generates you some stocks, basically some data that it randomly chooses and how you should spend your money for your stocks, and then spits it out for you. And for a while there, I couldn't figure out what the vulnerability was, because I'm not very familiar, like, C programs. I haven't used those since I graduated from university 20 years ago. And so I was trying to figure out, like, I thought maybe it was the scanf, because, inputs are usual vulnerabilities, but this one was correctly checks the string length, and it's got an extra space there for the null at the end. And I thought maybe we could do something with this %d, ranting a really big number, but that just would cause integer overflows, but it wasn't a vulnerability to read the flag. So that wasn't very useful. So I did some investigation after I recorded the video, and found, and then I also enlisted the help of my friends from the Legacy Code Rocks community, which you can check out. Oh, maybe I'll do a little plug for that there. So if you're interested in legacy code, there's a Legacy Code Rocks community. There we go. And they have, aside from some podcasts, they also where's the little thing? There we are. Community. So they have a Slack channel, and they also have virtual meetups, which I help co-host. So last time I co-hosted one, we all kind of paired together on the Stonks problem to try and figure it out. But none of us are cybersecurity experts. So we did have some C people on there, but even all of us were struggling to figure it out. If you don't have that vulnerability mindset, or you don't, I guess with a lot of cybersecurity problems, if you don't know, it's like a trivia question. If you don't know the answer or this like a possible solution, then you could just really get stuck. And again, that was the problem with us. But there was some useful advice where eventually, kind of even after we did our virtual meetup, we kind of figured out it was the printf format string. And I actually found that out when I tried to, I hadn't compiled the app, but I tried to compile it, and I got a warning about the printf string. So, but anyway, you should attend the virtual meet. I'm getting off topic here. You should attend the virtual meetups or join the Slack community if you like talking about Legacy Code Rocks. All right, so let's go back to here. So the actual exploit, and again, this is people who have done these kind of competitions, are familiar with C, probably know this. The actual exploit is this printf user buffer here. And the reason it's a I don't fully 100% understand. I guess C is just such a trusty language. But because there's no format string here, this is just a variable that you're outputting, is that you can put whatever you want in this variable. So printf has a bunch of substitutions and stuff you can do. Like you can say print this as a decimal, print this as a string. But you can also do things like print hexadecimal. And usually a printf works by having, like you'll have some like blah, and then I think it's like $1 or something like that. So again, I haven't used this in a while. And then this would print out the string blah, and then the first user buffer would be replaced here. And I think you can format it like I think this %s would use this first variable, something like that. But if you don't do any formatting, if you just print out this, whatever the user types in, and it finds a bunch of arguments, and like there's a bunch of like substitutions like %d, like show a decimal number. Printf will just keep climbing its internal stack of variables in the application, and just basically print those off for you. So it's a very trusting language. I think future versions have gotten rid of this problem. It wouldn't surprise me. Like this is a big issue. Yeah, and I guess I'm not really doing a good job explaining about it. So I would highly recommend that you go read. There's the OWASP here. I'll try to remember to put that in the video links below. That talks about how the format string exploit works. So right, here's the different, you can print things as decimals, as a character, string is a common one. In this one, we're going to use hexadecimal, I think. So I've actually haven't solved the Stonk problem, but in the actual picoCTF competition, I ran into a similar problem and was finally able to figure it out. So I'm going to use the same technique I use there, and hopefully it works. So then you can see example here, right? Like this %s, we'll take this first argument here. But if you just pass in anything, right? So, if you pass in a string of just hello world with a bunch of %s's, the first line will just treat those %s's as strings, and the second line will treat them as actual arguments, or the vulnerable code down here, as reference to string pointers, and then it will just climb the stack looking for, like if there's 1, 2, 3, 4, 5, 6. It's going to try and print out 6 strings it finds on its stack. So we're going to take advantage of that to try to figure out the API vulnerability. So let's see. Right, because basically we're going to, so this variable, so there's 2 types of memory in applications, at least in C applications, probably in other ones too, is there's a stack. So that's all these like statically declared variables. So when you declare this array, this gets added to the stack. Similarly, when you call a function and you pass in a parameter, this pointer will get added to the stack. Every time you call malloc, where's a malloc call? Here. This is going to add it to a heap. So that's a different memory location. But what we're going to take advantage of is the stack. So when we do here, we'll be able to say, we'll actually be able to read our own buffer back, but we'll be able to read other variables on the stack, such as the pointer to this, we'll be able to read these shares, this money variable, and eventually we want to get to this API buffer. So let's just try it. I'm talking a lot, and maybe none of this will work. And then you can see, I don't think we did this in the last video, but you could see with some of my friends from Legacy Code Rocks there, we were trying a bunch of different things because we were doing some reading about exploits and stuff. So, and I've also learned another technique that's kind of cool. Instead of writing these goofy test files, is I see a lot of people, they like to create a little Python file. So I think that's what I'm going to do here. This is what I did in one of the other ones, with the Pico, the actual Pico's competition. So I created a little payload. So and then they like to put this AAA just so you could find this on the stack. And then you do like a $%x. And then you'll do it like a whole bunch of times. So say like 100 times. And then you don't have to try and cut and paste that all in there. And then when we run, so the way we could compile this binary, but there's actually an online using netcat. We can access this online, and and that's where the actual flag is anyway. So let's just make sure this works. Yeah, so you could be a portfolio. You don't have anything. Buy some stonks. You just enter whatever. It doesn't matter. And again, it just randomly generates it. So every time you see, you get different stonks all the time. So let's try it with our payload. So we're going to take our payload, which is a Python application, and we're just going to, you can see I've done it for, in this case, we want to do this. Oops, sorry, I goofed that up there. There we go. Into there. So let's see what this gives us. Oh shoot, I forgot. There's one other thing we have to do for this application. Is the first thing it asks you is it asks you for this number. So we have to put the first one as a number. If it doesn't find a number, this decimal will just read the first character in your response. If it's not a number, well, it won't read the first character. It'll keep reading until it finds, as long as it finds a digit, a decimal number. So we need to change our payload to be, we want to buy 1 A. Okay. Yeah, there we go. So now we can see it printed off all this gobbledygook here. And these are all the hexadecimal representations of the locations, of the stack locations of what's in memory there. And kind of a trick I learned is the reason you put this A is because you're looking for like 41, 41, 41. And let's see if we can find it. Watch this not work for this particular example. Well, maybe I'll try a bigger one. Let's do 300. And then, do I see it there? Uh-oh. And then let's just grep this through. Looking for 41. Oh, no, we don't see it. Oh, interesting. The other application, I could see it. I don't know if that's... Oh, there we go. Well, that's not the 41 that we want. Okay, but it's still, we still might have what we need in here anyway. So what I'm going to try and do is I'm going to copy this. Oh, actually, sorry, I'm going to change this to be 08. I don't think we need. Sure, let's see 500 in there. And this is I want to pad all the values with 8. So because some of these hexadecimal values just show up as 0, it's just going to make it easier after the fact. So there we go. So we got some data there. So I padded all these with 8s. I wonder if this is a 64-bit app. Okay, so let's, because that was a problem I had with another one, is it was a 64-bit app. Let's see if I can see anything useful in any of these. So if I go from hex, all right, yeah, there you could see the flag right there. Now I had the same problem. The other thing to note is, so basically this is the value where it's somewhere. Let's see if I can find it. Let's see, this 6 is a null. Probably this, maybe this one here. Let's see, is that 6 close? Boom. Oh yeah, it was pretty close. Try this 3. Oh, too much. Oh, maybe it's the beginning of this. A2, A2, maybe the 6. There we go. So that's the start of it, is that 6 there. These are, the reason they're all backwards is because of the kind of the significance of the hex numbers. So like this is, you should read this as like pico. So if you look, where was I again? Was it this 6? Yeah. So this is like the hex representation of P, the 70 here, and I, C, O. So we actually need to turn each one of these around is what the problem is. So this is backwards. This one here is back. Like they're all basically backwards. So we could do that with the N. There we go. And there we go. There's our answer there. I lost all my money. So hex, yeah, it's 4. Yeah, so that takes all the hex values and basically, so when it sees 70, it's going to swap it. Like, I wonder, let's see, there we go. So it took this 70 and swapped it out. Well, you can kind of see how it's trying to match it up there. No, it's not 100% accurate, but that it matched, like this 70 is now the first hex in this memory location, and then 69, and then 63. So you don't want to reverse like the whole thing like a string. You just want to take this 70 and put it at the beginning, and the 69 next, and then 63, and then 6F. So, and it just has to do with the significance, like when you have a binary representation as the most significant bit, or if it was a number, what bit represents the highest value? Is it on the left or the right? All right. So there. So this is one of those ones that, like, once you know how to solve it, it's really easy. But until you, oops, I was right here. Until you know that, it's, yeah, like it's incredibly difficult. So, all right. So we solved that one. Oh, it's only 20 minutes, so let's try one more. That's why I always say it gets me into trouble. So, Stonk's done. So yeah, there's this format string attack. There's also, maybe I'll throw some other links to resources I found useful, because this was pretty hard to understand, at least for me, and it's been a long time since I take computer science. Like, I kind of understand the stack, but actually, like, using these, doing these capture the flag examples really forces me to understand, like, I understand the stack in theory, that things just get pushed onto it and get popped off, but this really forces you to understand the actual implementation details of it. which I'm still struggling to do. So maybe again that'll be another future video where I try to explain to myself and to you, the viewers and listeners, the actual stack. So so I'll put some more stuff in there for people. I was just wondering, like, I don't see my payload in there. Okay, I'm just curious. Let's the AAA. How big do we need to make this to see the AAA? Maybe there's a lot on the stack. Oh, didn't like 1,000. There's 800. Do I see anything that looks... Well, maybe it depends which way the stack grows or something, but I don't see my 4141. Yeah, see, again, I don't fully understand how stacks are built. The last time I did it, I was able to find my... Like, I was able to find this AAA in there. 900 doesn't like. Probably going right off the stack and it's crashing. I think it was 41 was capital A's. Yeah, I'm not getting it, so. Oh, yeah, if you know more, if you want to, oops, not exit. If you want to help explain the stack, give me a shout too. I'd love to hear or leave some comments or post to some resources because I'm still struggling to understand the implementation details of this. So, all right, but this is solved. Great. I can tell my legacy code rocks friends how I solved it. And then seem like a big hero. All right, let's try this other one real quick. And hopefully it won't blow up in my face. Hopefully 2 successes. But again, I didn't say this at the beginning of this video. You're watching live coding, right? So, and oh, interesting. Right, and I think this is kind of important because I think a lot of people just watch polished videos and it makes people seem really smart. But a lot of those smart people worked really hard behind the scenes. They had lots of failures, like I'm actually recording, and yeah, to get to where they are. Success is a lot of failures. Yeah, success is standing on a mountain of failures. Okay, red. Choose red. Choose blue. Choose blue. Choose red. Okay. Find the flag being held on the server to get ahead of the competition. So I'm assuming it has something to do with the head. Let's just take a look at just a quick look at the source. I think I did take a look at this source before. I haven't done much else with this, so yeah, like there's not... Oh, it is a PHP file. Value, choose blue. Value, choose... Like, I wonder if we could send it different values. So this seems like a problem for Burp Suite, is probably what I would open. Or like, how does it... Does it matter what you send it? So, okay, so this one I think we're going to use Burp Suite and we're going to intercept those calls. So let's open up Burp Suite. It's probably better. Oftentimes I take the more complicated route where people have done a lot of these capture the flag exercises, know the shortcuts. Oh, that's fine. Yeah, thanks Burp Suite for providing this community edition. That's really kind of you. Okay, so let's set up a proxy. I'll have to open up the... Okay. Oh, I need that URL. Which is... Okay, let's get rid of some of these. We'll open that up if we need it again. Okay. Oh, I even wonder, I didn't even notice this index.php. Yeah, I wonder if I could even just muck with the URL. I have a need, whoops, Burp Suite. Okay. It's fine. Okay, let's choose blue, choose red, choose blue. Oh, the choose red one puts a question mark up there. Huh, that's interesting. Okay, so now let's intercept a request. Let's choose red. Let's forward that. Oh, it didn't do anything. So if we look, let's take a look at the headers. And attributes. Oh, I don't see anything. 1, 2, 3. Maybe I need to make speed a little bigger here. Just the form. Okay. Choose blue. Oh, let's upgrade insecure requests. User agent. Okay, this is where I'm kind of a dum-dum and I can't see where it's passing the... Where is it passing in the fact that it wants blue or red? Or... Oh, HTTP2. Guess we're staying with HTTP1. What is this? Title blue. To submit. Oh, it's a get and a post. Oh, that's how it's determining the... Oh, I didn't notice that before. So there's a get, and then there's a post. Okay. Okay, so I'm on red. I choose blue. So this is a post to index.php. Okay, and this one is also... Oh, this one's got a question mark on the end. And that's because it's a get, I think. Is that why? I'm not 100% sure, but let's assume that's why. So this index.php has a get and also a post. Oh, I'm not quite sure what to do now. What could we do to this? Because we could try sending another type form action. What are the other actions? Oh, there's Firefox. HTTP action verbs. Oh, do we just try the head one? Because it's called get ahead. Okay, let's try that. So if we, was it just head? Okay. There we are. Boom. So this is just, let's do head. Sure. Oh, it didn't return me anything. Oh. Red. That's fine. Well, should we try this one? Head? Is that all it is? Just head, I think. Maybe I'm missing something here. Request the headers that will be returned if the head request URL is in. Oh, it could just the content length. Okay. Okay, let's take a look at the hints. So I don't, let's see. Yeah, yep. Boom. Look at the responses. That's what we're doing. All right, but what are we missing? Do we want to try puts maybe? Do we try different, what are the different, there we go. Tried head. We try put. Delete, connect, options, trace patch. Oh, there we go. Put gave us something. Okay, maybe we need to go here. Let's do this. And then let's make this head. Oh no, I just want to send one. How do I do that in Burp Suite again? Oh, I want to send it to the repeater. This one. Okay. I'll change this to the head. Oh, there we go. Okay. Right. I just go. Oh, I probably could see it if I would have looked. Right. Okay. So let's go back to here to the intercept. Let's choose red. And then we send the head one. And let's forward that. We get this, but what I should have done is I should have gone and looked at the developer tools. Oops. How do I see the head? I don't actually know. Let's see. Let's try to just set the off just for now. View header info in Chrome developer tools. Oops. I'm already I'm just not. Networked. Oh, okay. I gotta go to the network tab. I probably have to send this request maybe. Oh, jeez. So if we right, and then let's put the intercept back on. Choose red. We do the head. There we go. Now, yeah, there's the flag right there. It's in the response headers. Cool. Okay, so that's another way we could have done it. Just copy that. All right, I think we're just gonna end it there because I got a lot to do today. Where's Firefox? There we are. So, oof. Hooray! All right. So, yeah, again, if you find these videos useful, let me know. If you like them, like, subscribe, all the things. Share them, especially just share them with others so if you found them useful, maybe others will. If you have constructive criticism or you have a question you want to ask in the future, you can send an email to ask@SaturdayMP.com. And yeah, I guess the last thing to do, if you really want to throw some money my way, which would be great, is you can go to, I guess you go to my GitHub page, but there's a Saturday Morning Productions one, so this is me. Oh, not the website. You can go to the sponsorship link here, Saturday Morning Productions sponsor, and throw a couple dollars my way. That'd be much appreciated. If you like these shows or the open source projects that we have on Saturday Morning Productions, we have a iOS checkbox that's kind of, well, for Xamarin, that's, well, now for Maui, that's a wrapper of this BEM checkbox. We have some extra constraints. This migrator is an application I wrote a long time ago to mimic Ruby on Rails migrations, but I archived it, but then I kind of unarchived because I thought I worked on a client that I originally wrote this for. I thought I might have to make some changes to it, but I don't think I am, so this is going to get archived again. But yeah, so, and if you have any other open source projects you think would be useful for me to work on, or you'd like to see me work on in one of these videos, that's something else. If there's a bug or something or like a pull request you want me to open, I'd love to kind of just walk through how to do a pull request and fix a bug. Yeah, something like that. Anyway, thank you all very much for watching. I really appreciate your time and attention. I know there's lots of other YouTube videos out there you could be watching. I appreciate you. And I hope you have a great day like today. It's nice and sunny, so I'm going to go for a walk at lunch today, I think. So take care, everyone, and I'll chat with you later.